Hey, AP Statistics, we're going to talk about Chapter 6 today. Chapter 6 is all about probability. So we totally switched from Chapter 5, which is about experiments and experimental design, and now we're back to some serious math, okay? So we're going to review a little bit of stuff that you should have seen in some prior math class when you do kind of like the one chapter of probability in like Algebra 2 or whatever other class you've had. So that's kind of what we're going to review just a little bit. Okay, so multiplication principle, if you can do one task in n1 ways, then the second task in n2 ways, then both can be done when you multiply them, n1 times n2 number of ways. So how many different 7-digit telephone numbers can be created if the first digit is not a 0 or a 1? Okay, so I'm just going to draw out like the little spaces, 1, 2, 3, 4, 5, 6, 7. So if the first one can't be a 0 or a 1, we're talking about single digits. Okay, so how many single digits are there? 0 through 9? There's 10. But we can't have a 0 or 1, so the first one is an 8. Here we're allowed to have repeats. So how many options do I have on the second digit? It's going to be 10. And since I'm allowed to have repeats and there's no other conditions, all of these would be 10. So this is going to equal 8 times 10 to the 6th. If we can't have repeats, I'm going to show you what that looks like real quick. Okay, so on the first one, we can't have a 0 or a 1. So there's 8 options. On the next digit, there's no other requirements except that we can't have the first digit that we used. So normally there'd be 10 numbers, but since we already used one, there are actually 9 options here. And going down, now we've already used 2, so now we have 8 options, and then 7, 6, 5, 4. Okay, so you'd multiply that together to get your answer, which will be significantly smaller than if you were allowed to have repeats. Okay. All right, how many outcomes are possible when flipping a coin and rolling a dice? Okay, so coin, you have 2 options. The dice, you've got 6, so together you're going to have 12. Okay, just multiply them. And we're going to talk a little bit about permutations and combinations. It does come up a little bit, but it's not one of the main things that we're going to talk about in this chapter, okay? So permutation, the thing that you want to remember is that order matters. There's no repetition, okay? Taking n distinct objects and selecting r at a time in order. Okay, so the notation for this is n permutation r. So n is your total, permutation is what we're doing, and r is how many you want to select. Okay, so in this case, this is order matters. So in this example, how many ways can 30 cross-country runners come in first, second, third place? Okay, we can tell the difference between who got first place and who got third place. Okay, so this is why this is a permutation. A combination is when the order doesn't matter. So if I just wanted to select 5 people from the class to go and be in a group, I don't care who got picked first, second, and third. It doesn't matter to me. So I'm just care about picking 5 people. In this case, the example I just gave, that would be a combination. So permutation, the order matters, we can tell the difference. Okay, so the notation for this is we have a total of 30 runners. We're going to do a permutation, and we want to select 3, first, second, third, 3 places. Okay, so just following this formula, do you remember what this, like over here, the like exclamation mark means? That it's a factorial. That button is in your calculator. Okay, all of these buttons are going to be in your calculator. When you go to math and then go over to PRB, probability, there's the permutation button, and then you'll see number 2 and number 3 are permutation and combinations. So this is where those are in your calculator. Okay, so this, writing out in a formula way, would be 30 factorial over 30 minus 3 factorial. Okay, in your calculator, if you needed to write this in your calculator, you would write 30, then you'd go get NPR, and then write 3, and then hit enter, and it'll give you your solution. Not all of them, though, you need to do in a calculator if you understand permutation, or factorials, really. So this is 27 factorial. Okay, factorial means that you're going to multiply every number from there all the way down to 1. So this, think about it, this would be 30 times 29 times 28 times 27 times 26 all the way down. Can we tell what's going to happen on the bottom? This is 27 times 26, 25, da 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 da. All those are going to cancel all the way down. So really, it's just 30 times 29 times 28. Okay, so you can use your calculator. You can also use your brain, you know, whatever you choose. But multiply it out, and that's what you're going to get. All right, combinations. Again, the order doesn't matter. You're taking n objects, distinct objects, and selecting r at a time. So n factorial over n minus r factorial. We have this other r factorial here because we don't care what order they're selected. Someone selected, if I select 3 people, so say their names are Ryan, Sam, and Martha. I don't really care if Ryan comes first or he comes third. It's the same group of people. So that's why I have to divide by 3 factorial. Because to me, the group is the same 3 people. It doesn't matter if they were first, second, or third. Okay. Okay. So here we go. 3 marbles are drawn from a bag containing 3 red marbles and 5 white marbles. How many different ways can you draw the 3 marbles? Okay, careful with your questions. This is how many different ways. It's not asking a probability. We'll see some where it asks for a probability. Okay, so total, how many marbles do I have in the bag? I've got 8. We're going to do a combination, and I want to pick how many? I'm going to draw 3 marbles. We're going to draw 3 marbles. Okay, so I'm going to have 8 factorial, 5 factorial, 3 factorial. Okay, I'm just following the formula. N minus r, so 8 minus 3 is the 5, times r factorial. Okay, so again, if you understand factorials, not all of these you need a calculator for. I'm just going to write this out so you can kind of see, but a lot of these you can end up just canceling out. Now we have a 5 factorial and a 3 factorial. So 5, 4, 3, 2, 1, that's going to cancel all with these. 3 times 2 is 6, so that cancels up here, and you're just left with 56. Okay, so the better you get with these, the easier it is to have to not use your calculator. But it's fine to use your calculator, you always can. Okay. How many different ways can you draw 1 red and 2 white marbles? Okay, general probability rules. These are very general. Okay, so this isn't going to apply to all situations, but normally when you're looking at general probability like this, an and means multiply, and or usually means plus. Okay, you have 2 situations. So this is an and. Okay, so we want to look at how many total, we want to draw 1 red. How many total red are in the bag? I have 3. So we're going to do 3, and I want to choose one of them. And so I'm going to multiply. There are 5 white marbles, and I want to choose 2 of them. Okay. So that's the red and the white. Okay. So go ahead and see if you can calculate that, and we'll get there. Okay. Again, you don't need your calculator for this. The numbers are small enough. It's very easy to do by hand. This comes out to be 30. All right, example 5. Yeah, so card situations come up in this chapter a little bit. So we'll talk about this in class, just the breakdown of, well, maybe we'll just do it right now. There's 52 cards in a deck. Okay, so not everybody is familiar with a deck of cards. Okay, there are 4 suits. Okay, the 4 suits are clubs. Let me see if I can draw this. Sort of. Clubs. Ooh, that is a really bad spade. Spades. Then hearts and diamonds. Okay, these 2 are black. And these 2 are red. How many cards are in a suit? There are 13 cards in each suit. Okay, and they go from ace to the A all the way up to a king. So 2, 3, 4, 5 up to a 10, and then there's a jack, queen, king. So for example, there would be 4 kings in the deck. 2 are red, 2 are black. Okay, so it's kind of a little breakdown on cards. Okay, so what's the probability of getting, consider a process of selecting 3 cards. Okay, so this is what we're doing, 3 cards from a well-shuffled deck. What's the probability of getting 1 face card with replacement? So with replacement means that I'm putting it back in the deck. Okay, so replacement, which is not normally how you play cards, but you take it out, look at it, put it back in. Shuffle, take it out, put it back in. Okay. So what we want to look at, so normally what I have students do, like, okay, so then first off, what's the probability of getting a face card? Okay, so I'm going to have a face card, and then I'm going to get some other card, you know, like a regular card and another regular card. Okay, that's what I want to find the probability of. So with replacement, the face card, how many face cards are there going to be in the deck? There's going to be 12 out of 52. How many non-face cards are there then? There's 40 out of 52. And since I'm putting them back in the deck, there's still another 40 out of 52 because we did it with replacement. The thing is, does it have to be in this particular order? Does it have to be the face card first? No, it could actually come in any order. So really what we have is we want the probability that we get a face card and then a regular card. Or we have the probability we get a regular card and then a face card and then a regular card. Or we get the face card last. So we get a wow, sorry. Woo, I don't know what I picked. Sorry, regular and then face card. Okay, so how many ways is there to do this? There are 3 ways to do it. So 3 ways times 12 out of 52, 40 out of 52, and 40 out of 52.